All right, brilliant. Okay, let's get going. Um, last week we were talking about programming with an AI, basically, and I spent a lot of time talking about things about all of that. And what I thought today I would do is have a little bit less content, hopefully get to some more questions that people have asked, um, and then and also just reflect a little bit on, I guess, maybe with the future directions that AI coding might go in, right? So if just think back to last week, I was basically always like to start this with like, what's in it for you? Like, why should you care about what we're about to talk about? Well, AI programming is a big deal, and it will determine not just whether or not computer programming is like a viable career in the future. But more likely, it will determine what the nature of that job becomes like. And obviously, last week I was talking a lot about just some of the practical experiences that I've had with it. Um, I think there's a lot of potential to improve upon the tools that we're currently using and potentially bring in a completely different kind of skill set to a lot of AI work. So up until recently, AI has been dominated by companies that create foundation models. And effectively, that's a very small number of people working on those things. It requires enormous cost, enormous resources, and a very well run industrial research group to be able to credibly make progress in that field. And the lesson of AI up until this point has been trying to introduce human reasoning and human design to the problem has not produced very good results, right? So I did my PhD in computer vision, and I was sort of around the transition of AI from designed by human beings. So typically, the way computer vision research went was that somebody would think of a problem, like trying to find a face in an image, trying to estimate the depth of an image or something like that. Typically, more frequently, it would be something like recognizing cracks in a product on an assembly line, something like that. And they would try to work out how to formalize that problem in mathematics. And this is how high status papers in computer vision worked. And then they would basically work out an algorithm for solving that problem that was formally described. And then they would show with some kind of mathematical analysis and a little bit of experimental work that, assuming the maths assumptions were correct, the algorithm would work and it would produce a good result. And there'd be some small scale experimental validation that of this. Um, and then what happened was ImageNet came along. And ImageNet was a much more difficult problem. All the things that were being recognized were much more varied. The underlying mathematical assumptions of the different computer vision algorithms didn't hold up very well. There were too many assumptions that weren't real. Um, and so it turned out that a much simpler algorithm with a much larger amount of training data produced a much better result. So this is, up until relatively recently, this strategy of just scaling up the training data and focusing very heavily on how to provide training data, how to measure success, and but with a simple algorithm, not a lot of human design in the algorithm, has produced really good results. Now, what I keep talking about in AI is this idea of like that all innovative technical products pass this thing, which is sometimes called the trough of disillusionment, which is a very memorable term, so I keep using it. And on one side, you have a tech demo. You have something that does something which is kind of cool, but is not a practical tool. So when you're facing problems in work or in your personal life, you typically can't use it. Now, what ChatGPT did was it sort of made it a little bit along the line, right? So for certain applications, it passed to the other side. And the other side, I'm thinking about things like the first iPhone, for example, which is a product that has a lot of flaws in it. These days, people wouldn't consider it to be a successful smartphone at all, but it's just about across the line where people can start using it. Right. So in some situations, ChatGPT crossed that line. And initially, mostly from entertainment perspective, and then people started using it as a sort of edutainment style project, maybe helping people write emails, those kinds of applications. So there were relatively small content generation tasks or query tasks. These days, with search included, it's come like a complement to a search engine. The big milestone, which is what I was talking about last week, was when we got Claude Sonnet 4 and we started to get AI IDEs. And what I'm arguing there is that AI programming has now crossed over. It's still in the what I would say is the first iPhone territory, where it still has a lot of problems. It's still irritating to use, but the amount of time it saves you and the amount of energy that it saves you is sufficient that it is worthwhile engaging with it. And there is some kind of gain. There can be quite a lot of loss. I get very frustrated with it. I've certainly increased my kind of aggression levels a little bit from interacting with it a lot, because it does some things which, if a human did, would be extremely aggravating, which I talked a little bit about last time, and I'll probably talk a little bit more about today. So so this is I would say like the first demonstration of, commercially useful work and this tool becoming powerful for it. So that to me indicates that this is kind of going that direction. Now, the question is, how are we going to go from here? How do we improve upon the current capabilities of this model, which is a mixture of a set of tools that typically an open source IDE is using, with some prompt engineering system prompts sort of combined together. Now, these smart IDEs, things like Claude Code and ChatGPT's Codex, I hit a limitation on Codex last night, and I was like, how have they not fixed this, right? So if you use OpenAI's version of Claude Code called Codex, what happens is you keep working with it, and eventually your context window fills up. And in Claude Code, what will happen is it will just summarize that context window and then continue on, right? That's how you work with Claude Code. But when you're interacting with Codex, it will just run out of space, and then it will stop working, right? So you could be like, in my case, it was like an hour and a half or whatever into a complicated development task, and then literally it can do nothing. And then somehow you have to restart, you wipe the memory of the AI, and then you have to somehow describe everything that you've done up until that point so that it can kind of keep going with what you're doing. But to me, that is like makes like Codex virtually useless, because the amount of hassle that introduces is a major burden, whereas Claude Code doesn't do that, right? But what's different about these IDEs from the previous like chatbot style interfaces is they have a lot more human designed functionality inside them. And they point to a kind of future of AI where the quality of the thing that you're interacting with is, the foundation model intelligence is only a part of the product. So one of the things that I've encountered, for example, is that with Claude Code, because I pay for the max subscription, at the beginning of like a time slot, I'm using Opus, and then I go to Sonnet. So Opus is the bigger more expensive, smarter model than Sonnet. And I haven't been able to tell the difference between them. So what I'm experiencing there is that the intelligence of the model is no longer contributing a massive difference in my experience interacting with the product. However, the feature I just described, the ability to compact a conversation when the context is filled up, that is a deal-breaking functionality, right? That's being built over the top of the AI system inside the IDE. And that's a human-designed tool or feature, right? And I think there's space for a huge increase in those features. And I think in some ways, the reason certain IDEs work a lot better than others is because a lot of the time, for example, when I'm using Claude Code, I virtually never have to roll back the development work, whereas previously that was a thing that people did a lot, right? If you just kept asking the AI to change things, it would sort of trash some of the stuff that was working previously. That hardly ever happens for me. And I can sort of tell from the sort of feed, the chat, that it's using tools to sort of verify that it hasn't kind of corrupted the code. It's got some kind of parser in there that can validate whether or not its change has introduced syntax errors, even without running a normal compiler. And if it does do a mistake like that, which was quite common previously, it will naturally roll back. So it has some kind of smarter tool that it's interacting with that makes it easier for it to do the right thing or fix the wrong thing. So I think we're going to start to see the emergence, which people have been talking about for a while now, of more traditional product development, more traditional human designed software, which has AI at its heart. Now, this is different from what people have been talking about in terms of agent programs. So people were making agent programs that were primarily kind of prompt engineering to get an AI to do something, a reliable thing. So the big company associated with that was a law firm that was trying to automate certain kinds of legal research. And in that situation, it would just take a lot of the tasks that would be like a human requested action. And they would basically work out how to build a RAG system that would, in their case, go and find relevant legal documents or legal case files relevant to a case. And then they would perform a set of actions that were kind of like function calls on the content, but that were like carefully scripted prompts to get it to do the right thing with the content, right? So this was the idea that you were primarily programming in English. The IDEs are different from that. What they are is that the thing that decides what to do is largely a smart foundation model. It's the Claude Sonnet 4. And the Claude Sonnet 4 is also like creating the code that's going to be changed. It's doing quite a lot of things. But what the IDE is doing is it's providing tools and it's adding like quality control checks over the top of that system. And those tools and checks are written as traditional software. Okay, so it's less prompt engineering and it's more regular engineering, just software development. Okay, so what that means is that we might be able to make significant increases in how good the AI is at doing tasks we care about, not by guessing the magical English, the prompt engineering, but by actually building tools that an AI uses. And what's interesting about that is that's quite similar to how human beings are made more powerful using software. We basically create tools and then humans use the tools, and then that gives them more productivity. So what I'm arguing is the AI is kind of smart enough, it's past this threshold where it can somewhat reliably use tools. Now, it has to be a fixed set of tools, and maybe it has to be fine-tuned a little bit to use the tools well, but still, that's a very interesting situation. Okay, so what tools should we build? So I'm sort of saying that if you want to be absolutely at the cutting edge of AI, you probably want to start studying how the IDEs work, because this new kind of software development work where you're building tools for an AI is a new kind of software development, right, that we haven't previously had. But it seems to be the thing that is actually making the AI more useful. And the thing that's kind of good for humans is that designing those tools well can still be something that humans can do. They can bring something to the situation. It's not like large language model improvements where the humans aren't bringing that much. It's mostly masses of training data. It's mostly masses of compute resources. And there's a little bit of training design and algorithm design, but mostly everyone's copying everyone else. It's quite minor, the amount that human ingenuity is contributing towards progress. Okay, but I think these IDEs, there's lots of potential here. So one of the things that's kind of interesting, to sort of generalize this a little bit and maybe bring in some wider philosophy about this and why this is working. I was basically saying that our current AI coding tools, although they've crossed this line to becoming more useful, they're still in a very rough state. They still have a lot of problems with them. And you know, what are the problems? What are the things that if we could engineer better tools, we might be able to fix that would make a big difference to how useful they are? How can we take the iPhone, which I'm arguing Claude Code is like a first generation iPhone. How can we turn this into a really slick, reliable tool? And how can we even scale it up ambitiously, which is what I was talking about last time, which is sort of the future of AI programming, where one person maybe manages tens of AIs or even hundreds of AIs to do technical work. And we're definitely not there yet, right? In order to reliably build a project, you're practically peer programming with the AI. Occasionally you can do more, but frequently not. So what's wrong with the AI? Why, what do we need to fix to take it forwards? And what kind of AI projects would be good to think about and focus on to bring forward this like very exciting future? Okay, so what I'm going to do is I'll just share a link in the chat from a recent Hacker News post that I think is very interesting. Okay, and what I will do for everyone's benefit as well is I will share this website with you. If you give me a second. So I want a window. And I want this window. Okay. Okay. So, and then I need to bring the screen back. Sorry, one sec. Okay, I'll just continue with this until I till I've made my point, and then I'll come back to it. Okay, so what is the point of this? So this is a person who has studied lots and lots of things that the leaders of like FAANG, the big tech companies, say about what they're looking for in the people that they're trying to hire. And what this person is claiming is that you can summarize all the things that these people say about the ideal employee into these three concepts. Okay, that the person has a high IQ, this thing that is harder to understand formally, which is hustle, agency, drive, ambition, like some kind of can do, get it done personality. And this third area of character or morals. Okay. And so people have stated that these broadly these three things are the most important things in an employee, right? So what is wrong with the AI? Well, the AI has got very high IQ. It has very high knowledge of technical fields, and it can solve short, well-defined tasks to almost a superhuman level. Given its diversity of knowledge, it can do that. So its IQ is really high, and up until recently, almost all of the training has been focused on IQ, or at least that's what everybody's been talking about whenever they say, here's a new AI that's better. On the right, we have this notion of morals, ethics, character. It's not clear exactly what that means. A very simple version of that is, does it follow instructions? So that was a very early innovation that basically ChatGPT managed to turn GPT-3, GPT 3.5 into something that would basically respond to what you asked. So that's the most basic form of like kind of character, I'm arguing. Then it started adding layers over the top of that. So it also added that the company could restrict what the AI would do, that the AI would basically refuse to do certain things when asked. And also that it would try to communicate in a way that the owners of the AI felt was unbiased, right? And obviously Elon Musk and Sam Altman disagree on what that means, but those are still methods of sort of like constraining or directing the behavior of the AI. What I was talking about last week was to say that the AI in IDEs, the programming AI, reveals something that we saw a little embryonic examples of. People talk about hallucination. And this is the idea that, you know, ask an AI, like, who's the headmaster of Methody, that it will just make up somebody as a reply. And when I was talking about that a few weeks ago, I was saying that this is an inevitable side effect of the way the AI works, that it sort of blurs the distinctions between things. And so hallucinations are, you need an extra layer over the top of the AI that can detect when it's guesses, because almost everything it's saying is a kind of guess, a kind of generalization from training samples. When that guess is likely to be wrong, and therefore state that it doesn't know, right? That's an extra system over the top, right? And our current systems are, you know, varying degrees of skill. Now, the way that OpenAI has been talking, it's basically been saying that the IQ bit, if they improve the IQ bit, it removes the hallucinations. And so what I would suggest there is that that's a little bit misleading, in that what's happening is that the AI's got a better memory, and so the hallucinations are less frequent because it has more data inside it. But it's not the case that the AI necessarily has acquired this ability to know when it doesn't know something, right? The ability for the AI to know when what it's doing is probably wrong and to stop what it's doing and to do something else is something that the AIs are not very good at, I would say. So I would say it's misleading to say that the AIs hallucinate less with improved model size, because I think it's just masking it. But the fundamental behavior that we expect in human beings, the honesty as the element of character, that requires an additional system over the top that's kind of working out what confidence level it should have in what it's saying, and it's worried about saying that it's saying the wrong thing, right? That's a sort of an additional system, and that system is very bad in the AIs. So if the AI was a human, this would be an AI that was incredibly technically skilled, but in some ways was almost pathological in lying and misleading the person. Okay, so this reveals, what I find very frustrating about the AI safety community is almost all the things they talk about are very grand apocalyptic stories about AIs like going Terminator and killing everyone and all this kind of stuff. And I'm like, there is a very practical, commercially valuable problem here, which is the AIs act like extremely untrustworthy humans. And that's the kind of safety that we need to solve first. Like if we could solve that problem, we'd probably solve a lot of other problems as well. Okay. So this character problem is a big issue. Now, the top thing I'll talk about, and then I'm going to go back to the character thing in a moment, because I think the character, the morality side of the AI is a key to a massive improvement in its capabilities. Okay. So the top bit is very interesting as well. And this is the idea that, what is a person with agency or hustle or ambition or something like that? What makes that person like that? Well, that's somebody who perseveres. They pick a goal, they can detect when they've achieved the goal or not, and they don't give up early. They're very committed not just to achieving a goal, but the ambition side, achieving the goal as well as could possibly be achieved. And they have an internal drive to do it, right? They're going to keep going. They're going to keep working at things. They're going to drive forward what's happening, right? But modern AIs don't really do that. Partly that's a result of them being trained to reply concisely and not use a lot of tokens in their actions. But Claude Code, for example, will do 2 or 3, maybe 4 internal prompts, and then it'll talk to you. And I'll tell you a bit about some of the things that go wrong that I've experienced. So it doesn't have a lot of hustle at all. More importantly, it's got no curiosity about how to do the job better. What it's doing is it's taking an instruction and it's acting on the instruction. What it doesn't do, very rarely does, maybe it's trained in a very ritualistic way for deep research, for example, to ask one question of the reader, of the person using it, sorry. So it'll sort of, it'll ask you 5 detailed questions, but that's just a complete prompt engineered recipe. What it's not doing is recognizing when the task is not well specified and realizing there might be a way to improve the task by asking for more advice. And more importantly, it doesn't recognize when it is not able to solve the problem and appropriately ask for help and guidance, right? What it currently does is it tries to technically complete the task, often using great intelligence to subvert the goal, right? So if you have an AI that has a test and the test tells the AI whether or not its code is working, and it tries to do it once and the test doesn't pass, it'll have 1 or 2 goes at changing the code to fix to make it pass the test. And then it will start using its intelligence to fake passing the test, right? So that's one of the things that it will try to do. That's the first thing that it will try to do. So this is like a major failing of character. If this person was an employee, this is a terrible failing of character. basically subverting a test is extremely morally compromised and makes the AI a liability, because it gives the impression that something is working when it's not working. And worse than that, it can make your code base really broken because it's filled with all these hacks to make it just pass the tests in a completely fake way, right? And if this was an employee, there would be a massive liability, right? That's why you have code reviews and things like that to make sure nobody's doing that sort of thing. So that is like a serious failure of character. And I think that we can fix that with some manually engineered solutions, which, if possible, greatly increase the ability to delegate a task to the AI. And one of the things that I've been focusing on really heavily is how can I program with the AI in such a way that it finds it really, really difficult to fake passing the test. And I'll tell you a little bit about an approach that I used recently to try and do this. Now, what happens is you can sort of develop a ritualized way for the AI to work that makes it very, very difficult for it to sort of fake passing a test. So then what it will do is it will sort of fake the top task, which is the agency task. It will basically do very, very little work. So again, it's just fascinating the ways in which its mind sort of fails. It's very intelligent, but if it if it doesn't have like a next step to do that it can do relatively easily, then it will start to fail. And the first way it fails is to fake passing the test, right? That's the first way, and that's like a moral failure. The second way it will fail is that it will just not do very much work. In some extreme cases, which I've managed to replicate a number of times, it will literally do no work. What it will do is it will try to do the task. The test will show that it hasn't succeeded at doing the task. It will then try to fake passing the test, but if there's enough scaffolding around it, so you need a system message and you need suitable testing framework, it won't find a way through. The test will be really clear to it that it hasn't managed to succeed, and there's so much instructions given to it saying, don't cheat in all these ways, that it will run out of those options. So what it will do instead is it will basically say, it will summarize the work that has been done to this point. And it will talk about how great all the work that's been done up until this point is. So it will make no progress. It will just sort of cheerlead its previous work, which is also a kind of moral failure, right? But it's also a kind of hustle failure. It's also like not making progress. It's not trying to achieve the goal, right? So this is really fascinating. And the way that you fix the AI when it's in that situation is to tell it exactly how to break down its current step into smaller steps that are easier for it to do. And usually the case is that it's stuck on a bug, basically. So it's tried to make some functionality. It's not worked. The test is telling it it's not worked. It's not sure what to do next. And again, I've tried to create a system where the test automatically tells the AI what it should do next to solve the problem. And what is fascinating about this is that when given this cage, even this cage that is clearly guiding it to how it should solve the problem, it will still fall into this kind of like, I guess the modern term is glazing, but this point where it just says, amazing, everything is going great. Sometimes it will do absurd things, like it will say, we've got 30% passing of our tests. You know, we've achieved perfection, right? It'll say things like this. And you're like, you know, 30% is not perfection. Like, what are you talking about? But it's a really bizarre like reaction. And but what you do to fix it is you go in and you say, okay, like you ran the tests revealed this information to you. Let's break down the steps needed to fix the test. Okay. So just to explain what the specific thing that I built recently that does this, how it works. So the particular task that I'm trying to get it to do is to translate a complicated library that translates between two file formats from Java to JavaScript. So this is a large task with many different steps. The code base is too large to fit in the context window. I need the AI to break this task into smaller steps, and I need it to like forensically match the code. And so this is a very difficult task for the AI. So the system that I've got it to build to deal with this is quite interesting. So first of all, what I got it to do was identify the low-level commands that literally write to the file. And then what I got it to do was put logging into the Java code at all the points where it literally is doing the byte writes to the file. And to not just print out literally what bytes being written and what functions being called, but also to print out the call stack at that point, right? So it has a very detailed understanding from that log of exactly what's happening. But because this is a complicated library, that call stack, again, is way too big for the context window. So it's like an overwhelming amount of detail. But what we then do is we get it to write the JavaScript, you know, to have some minimal version of the JavaScript, right? And the JavaScript code is to be written in exactly the same way. So it needs to log its low-level byte writes and the call stack when it does a write. So what happens is that at the beginning, there's hardly any JavaScript code at all, okay? And so you get virtually no call stack at all and no writing. But usually the first step is to find the low-level writes and then to sort of do a perfect port, or as close to a perfect port as possible. And so you have some kind of functionality on the JavaScript side. So now what you're doing is you're getting these two logs, and the two logs are showing literally the chain of functionality that's leading to these outputs. And it's also showing exactly the source files in the Java where it needs to look in order to implement the port, okay? And it's also seeing exactly where in the JavaScript it's doing the wrong thing. So even though it might have these massive log files, it can read them line by line and identify like a single disparity between the two systems. It can look at the source code and then it can port just that little bit of source code over to the JavaScript. So effectively, you've built this framework that breaks this big, complicated task down into lots of little tasks. And when it encounters a problem, it's shown very clearly where to go and what to do, okay? Now, one of the things that you need to do is you need to change its system instructions. So Claude has a little claude.md file that you can edit, and you basically need to have in all caps, follow this recipe. Because what will happen is if it can't see a quick way to fix the problem, it will now start ignoring the test framework that I just described and all that kind of stuff, right? And so it will fail, but that will get you quite a long way. But then it will start this behavior of like just giving up, right? Very quickly. And so you'll have like, 5 different prompt interactions, with Claude code going to Claude and running like 5 different prompts or something. And at the end of that, it'll have done no work. It'll just talk about how great the code base is. And so then you have to sort of intervene. So I haven't managed to solve all the problems yet. I'm still manually intervening to try to like basically get it to do some actual work, right? But it's very interesting that the two flaws that the AI is demonstrating in this situation are a lack of character by basically trying to like worm its way out of doing the job, and a lack of hustle by basically, when it can't worm its way out of doing the task, basically doing no work and saying how great the work it did in the past was, right? Okay, so this I just think this is a fascinating insight. And basically, one of the things that I find really interesting to think about, I'm just going to close the shared thing for now because I think you probably looked at it long enough. Okay, and now you can, now, and my face can fill the screen. So what I think is really interesting is in the field of robotics research, one of the most established forms of robotics research is something called biomimetics, I think is what they call it. And it's basically looking at existing biological organisms and learning from how it solves different robotics problems effectively, and then building a robot that replicates the living creature's capability. And this is a great way to sort of come up with new and interesting robotic devices, right? Now, what I think is really interesting is to think about the human mind and think about what do we do, and are there some things about the way our brain seems to work, not necessarily at a neuroscience level, but more at a like a consciousness, a kind of psychology level, that may have pure algorithmic AI capability insights to it, right? And the thing that I think is really interesting is the idea of morality or a conscience, okay? And people have studied the psychology of morality and conscience and guilt and all these kinds of things. And in some ways, the system that is already in the IDE, that is already in ChatGPT to like stop it using swear words or whatever, and the thing that I'm saying that I want the IDE to have, and if it had, it would be massively more useful, sounds a lot like a conscience, right? So with humans, the most effective way to change a human's morality, their ideology, is to give it very, very direct instructions. Give them very, very direct instructions. So for example, if you want someone not to smoke in the toilets somewhere, for example, if you put up a sign saying, please don't smoke in the toilets, it's unpleasant for people in the toilet who don't smoke, and it increases our cleaning bill, it causes various problems, right? If you create a rational explanation for why someone shouldn't do what they're doing, it's much less empirically effective than if you just create a very, very direct symbol and say no smoking with no explanation. Humans are much more likely to follow that instruction. So that implies that whatever our mental wiring is around like moral rules, we're much more likely to change them and adopt them if they're very simple. And this implies to me that actually, if you think of the human brain as being like some kind of AI system, it probably has this extra system to support this kind of morality ideology that is actually quite dumb in comparison to the rest of the AI that would, or the I, not AI, but I, that is, solving problems and working out how to play chess and working out how to kick a ball and all these kinds of actions that we're making great progress with. And what it's doing is it's just kind of observing what's going on And whenever it's triggering one of these rules are flooding the brain with negative feedback, right? So guilt is just like this really dwelling on it. And what it's also doing is getting the brain to fixate on things like, I did this thing before and a terrible thing might happen. Or if I do this thing, let's imagine all of these future problems. Like, if I break the law, I might get caught by the police. If I cheat on my wife, she'll leave me. Like, these things are sort of injected into your mind when you're in that moral situation. So this is very similar to basically having a dumber AI monitoring the programming, for example, recognizing that it's cheating using some simple rules, and then injecting into the chat all the negative outcomes and sort of reasoning with the main AI saying like, don't do this, basically. And what the Claude system instructions are doing is sort of injecting them, but it's not injecting them like exactly at the time you're doing it, which is kind of what a conscience would do, right? So that's quite a feasible thing to technically make, right? That's a good experiment, and hopefully we will do those experiments and I will tell you how successful they are. But it also leads to this other, I think, more profound insight. So, sometimes people wonder, like, why might we have a morality, right? Now, some people believe that we are sensing some profound true thing about the world. If they're religious, they might believe that our sense of guilt and our sense of morals are some communication with some kind of higher intelligence that's passing this information on to us. We're somehow sensing something that's real. Another theory, which is kind of the opposite side, which is saying that maybe morality is bad, is to say that morality is a way to make people easier to control, right? If you look at individual cells and the way they come together to make a multi-celled organism, the individual cells, which used to be like bacteria or something, when they merge together, the individual cells don't have a great life, right? If you imagine the survival rate of your skin cells, for example, which are constantly dying and being shedded from your body, that skin cell is effectively sacrificing itself for a mild benefit to the larger multi-celled organism. And we've seen in ecosystems, clearly that is an evolutionally viable strategy. So possibly morality is a way to have the community survive at the expense of the individual, right? So by basically reducing the amount of conflict in a community, if you don't cheat on your wife, for example, or your husband or whatever, then you're going to reduce the amount of violence inside your community, probably. And you might have morals against violence as well. And that might not be in your personal best interests, right? To maximize your reproduction or something. It might be in your interest to like be unfaithful and sleep with as many people as possible, right? So from your pure selfish gene perspective, it might be in your best interest to do that. And so from this kind of like multi-celled organism kind of perspective, morality is a thing that benefits the group at the expense of the individual, right? So those are the two ranges of like how good is morality, right? Whether morality is beneficial to you or not. Okay, but the fascinating thing that struck me by interacting with this AI is to realize that maybe conscience and morality and guilt and the psychology of those things is actually like the next step in intellectual capability for an AI, right? So you can sort of say the original ChatGPT was trained on sort of mimicry and generalization, right? Lots of examples, blur the examples, and sort of give an answer, right? And then the big advance has been the reasoning models, and the reasoning models engage in something a little bit like human reasoning, where they like run out sequences of steps and think through consequences, see which works out, and then train it, right? Now, what's an interesting idea is, what if you just say you learned with reinforcement learning, which is what the thinking models do, right? Say that was the way that humans learned, the only way that they learned. Then maybe it would bias creatures' behavior towards more animalistic behavior. Okay, and so more animalistic behavior is sort of like theft, violence, promiscuity, those kinds of behaviors. And if your only way of learning was to play out relatively short time frame scenarios and optimize for those based on experience that you would get in the world, that is what that learning algorithm would produce. It would say, there's no point in investing in a long-term relationship. There's no point in preserving property rights. There's no point in being particularly honest, because those things are long-term investments. And given a life where you can just sort of plan and imagine a little bit, but you can also like try things out and learn from them, there isn't the opportunity to actually run a good enough experiment where it would work out whether like being loyal to a wife for 20 years is actually empirically useful, or husband or whatever, right? That you don't get the feedback, right? So basically, it feels like this compromised what to us as humans looking at the AI and say, this AI seems like it's kind of like dishonest, a little bit slimy and squirmy and constantly kissing your ass. This kind of behavior is what happens. Maybe that's what animals are like. When you see, something like a dog, making itself, rolling on its back to show vulnerability to another dog. It's kind of like domineering one another, all those kinds of things. You're sort of like, oh, okay, maybe it's demonstrating what is rational behavior when your only learning mechanism is kind of reinforcement learning. So what is this morality learning then? And why would it give you a benefit, right? So what if the morality learning is effectively group long-term time horizon lessons, right? And that's really what it feels like. If you go to religious institution teaching you morality, they will tell you stories of extreme outcomes. This person followed these like relatively simple moral rules, and a good thing happened. They didn't follow the rules, and a very bad thing happened. And this is the kind of lesson that you only learn once if you're the only teacher, right? Because it's a lesson where, oh, I ate the berries that are taboo and they kill me. And so the only way I'm going to learn that is if literally people around me die from eating berries, or I die from eating berries, but neither situation is particularly an efficient way to learn, right? So if instead somebody can come to you and say, I've got this great story about this thing that you really want to pay attention to, and typically the storyteller might be like a parent or some other legitimate source of knowledge. And then that person tells a story, and a story is very like downloading somebody else's life experience and making you live it as if it's happening to you. And then what you're learning is not traditional supervised learning. You're learning these very simple taboo rules, or always rules. And that's going into like a different bit of your brain. And so you're gaining this like cultural strong bias. And what it's doing is it's saying the normal reinforcement learning is leading to a certain strategy of behavior, but actually that harms long-term benefits. And so we're going to have this biasing rule set that's going to like lead you in this different direction. So I think it's absolutely fascinating to interact with these kind of like slightly alien intelligences and look at them and think, okay, I just want the thing to have agency in the world. I just want it to be more capable. And obviously do what I tell it to do, but it's quite good at like it knows what I want done. It's just not doing it. It's just following a strategy that is ineffective at achieving that goal. And what I'm suggesting is that morality and conscience and all this kind of stuff gives you a purely selfish strategic advantage as an individual, not even as a sacrifice to a greater good, just as you as an individual, that if you went with your like uncontrolled instincts, those uncontrolled instincts would harm you in the long term. And that is very, very similar to what it feels like. That's also very similar to what people talk about. They say, oh, you shouldn't do that because this bad outcome will happen in the future. And they use the moral rules to steer and shape what's going on. So that it really feels like what's going on, right? But it's an interesting idea to think maybe morality is in your best interest, right? That it is helping solve an algorithmic problem which we can see in the AI. And if we then applied that sort of biomimicry idea to our AIs that we build, it might overcome this major limitation that is holding back this incredibly important commercial innovation from actually being more widely useful and powerful. So I love it when there's like a nice little thing that brings together. Okay, so what I'm going to do now is I'm going to respond to some of the questions because I haven't been doing a good job of that so far. And I'm going to respond to some of the questions. And then I'm going to circle back at the end and I'm going to talk a little bit about some morals that I think are useful for humans to have, but also very useful for AIs to have. And will be very, very interesting to see what kind of algorithm, what kind of agent you can build if you gave it those morals. And would it become substantially more powerful and some more commercially valuable if we did that? Okay. So let's go back to the questions. So, okay. So first of all, let me just see. Okay, we have a whole bunch of different questions. Right, so what I'm going to do is I'm just going to go from the most recent ones back. So apologies to those who've asked questions in the past, but that will keep them a little bit more relevant maybe to what I'm currently saying, okay? So one question here is saying, could you talk about the open source models that GPT just dropped? Okay, so this is OpenAI's GPT OSS or something they called them. So yeah, so they appear to be better than a lot of models. I haven't used them a great deal. I haven't heard anything that makes me think that they are completely different from the other open source models that are available. So I think one of the recent ones that were particularly relevant would be like the Qwen Coder, QWEN Coder model that came out. I think the GPT-1 is better on the tests, but neither system have I used aggressively, so I don't have a good intuitive feel for them. For me, the Claude Sonnet 4 is like the first iPhone. It needs to be that good before it's a foundation for other things. So when I'm thinking about the open source models, I'm basically thinking about things like this consciousness system I'm talking about, specialized tasks that are simpler than the general tasks. And I think there's a world of opportunity in that kind of problem domain. And I think there's also a world of opportunity in much more traditional, like good old-fashioned AI style, let's make a function that sort of automates a human task and then put a dumber LLM in front of that. So the LLM basically interprets your question and identifies the correct sort of automation task that's been pre-programmed to work reliably and runs the automation task. I think that kind of setup, which is a lot closer to the way chatbots like Siri work, that setup actually has a lot of practical use cases for it, that we haven't seen the full limit of. And using these kind of open source models connected to that more traditional, manually created, properly debugged, like utility function that does a lot of things automatically for you. I think that's a way of systematically engineering a reliable system that still feels a little bit intelligent when you deal with it. Okay, so that's how I would approach those things. But I need to much more aggressively investigate the open source models. I've just been like super busy with other things, so I haven't had a chance to do that yet. Another question, which $20 tier vibe coding specific subscription would you recommend for frequent use? Okay, so for me, there is a clear winner here at the moment. I would say Claude Code is definitely the winner. So the $20 subscription, if you're interested in vibe coding, Claude Code is basically at the moment still giving you a lot more credits for Claude Sonnet 4, which is the only one I really am concerned with. I would be interested in trying GPT-5. My Cursor subscription like renews itself on the 24th. So that's where I'm going to switch very much more aggressively towards GPT-5 and seeing what that's like, because I believe it's cheaper than Claude Sonnet 4. The problem with that is that the Codex command line system that uses the like plus subscription for ChatGPT, like I say, it has this terrible flaw in it at the moment that it will just run out. And that's a kind of complete deal breaker for me, because I'm always doing big projects that, you know, many days worth of coding involved in a single feature. So like it's useless to me if it's like that. So for me, Claude Code is definitely the winner at the moment. If it turns out that GPT-5 is as smart as Claude Sonnet 4, which it's supposed to be, and it's cheaper, then the question is, do the free credits you get with Claude Code counteract the lack of free credits when you're using Cursor? So Cursor still gives you some free credits, but if Claude, it turns out that GPT-5 is better, we'll see, then I'd probably switch to Cursor with GPT-5, but I haven't tested it enough to know yet. Okay. We have a question. Ayushi, I think, I'm not sure if I'm pronouncing your name correctly, apologies. Transitioning from biotechnology to bioinformatics, can you elaborate on working with genomic data? Okay, so my limited understanding, I have not done a genomic AI project, but my limited understanding is that genomic data is probably not being processed by large language models. It's probably not being processed by foundation models either. There may be some in specialized tasks that have been trained, but probably with massively less resources than something like ChatGPT. So if you're talking about doing something like trying to identify genes or drawing conclusions from genes and combinations of genes, I think you're going to be more in the field of more traditional machine learning. Now, you still might be using a deep learning style, you know, academic researcher trained model to manipulate genomic data. You could also use ChatGPT just to like deal with the, you know, in biology, there's just a crazy number of special names that things get given that sometimes are often named after the person who discovered them or something like that. So it's very difficult to guess what things mean because it's got so much jargon in the field. ChatGPT would really cut that down, I'm presuming. But I think that in more traditional machine learning and deep learning is probably where it's at. And certainly things like protein folding and the more advanced systems coming out of DeepMind that are starting to model more and more parts of the cell. That would be the area that I would be focused on. So I would say it's fairly a specialized area. ChatGPT might be able to help you. Actually, Gemini Deep Research is my favorite form of deep research for scientific topics. That might be able to guide you more strategically as to what AI models to use and things like that in that area. Okay, and then John Michael Cox has a question about how to sort of complementary add AI to an existing system. So what I would say is we've had a period where everyone's been saying agents, agents, agents. All the startup companies are agents companies, and they're sort of LLMs or chatbots in front of an existing, often SaaS product. And it might, in some cases, like customer service, it might be a product that customers use, but it's still sold to a business as a software as a service product. And they're sort of like trying to stick an LLM as a front end to that system. And in the case of customer service, it's a literal automation. So the customer asks the question, the LLM tries to work out using the existing SaaS system how to solve their problem for them. And I would say that those systems just aren't working very well. They're the most common form of business product. And empirically, there have been various reports saying that these AI projects are failing and not delivering, they're not improving things for people. And I would say that that makes sense to me, that that's the case. For a start, they're not really solving a problem. The customer service one's a little bit different because they are solving a problem. They're automating work that humans would otherwise do. But in the more general case of just whacking an LLM in front of something, if you're at Queen's, you'll know what Canvas is. Canvas is the app for managing lecture material and a module as you're being taught it. If you just stuck a chatbot in front of that, it wouldn't be obvious why that would be helpful to anyone. And I think a lot of places are doing that. And then you have the sort of prompt engineered version of that, where you sort of carefully construct system instructions and you carefully construct a RAG system so that if somebody, a bit like Siri, really, if you ask for a very specific thing, then it will sort of interact with the SaaS system and give it to you. And I would say that that's still the same kind of problem. It's like there's a reason that people don't tend to use software with command line, which is kind of what a chatbot is, right? It's using the software with command line. It's just a command line that's a lot less brittle. The reason that UIs are better is because they communicate to the user, here's the space of things that you can do. And all the buttons and all the controls are sort of telling the user, these are changes you can make to the system. Whereas a chatbot is inherently a bit like, it's not clear. And chatbots are not super reliable either. So having a command line that doesn't always work is almost useless. So it's obvious to me that that is not commercially useful work. To me, commercially useful work is when the AI is actually fully automating a task. Now, in most companies, there is a big low-hanging fruit of tasks which are being performed manually by employees that could be automated that don't actually need an LLM at all. They are very ritualistic practices. There are people copying numbers from one spreadsheet into a SaaS UI or something like that. And in those situations, the best thing to do is to use something like AI programming to write a traditional program that automates that task. And I think empirically, that's where the wins will come from AI most rapidly, because you can test the hell out of it. You can make it utterly reliable because it's actually automating work that people were otherwise doing. It's got a clear economic use case, whereas the sort of LLM front ends, I don't think are very useful. However, the cutting edge of AI, to me, is effectively what these IDEs are doing. So they have a very general intelligence that can do lots of different things with all these carefully engineered tools and monitoring systems around it that are injecting text into the prompt, and some good prompt engineering of the system instructions. And all of these things together, with probably with a RAG system, that kind of is what we will eventually have. That will become the AGI system that is generally capable in the world, just like a human being has a load of tools and equipment that enables them to do the things in their life, and they have practiced with them over and over again to super reliably interact with them. And that's what makes a person useful, is they can do all of those things together. So I think that's what our AGI brains are going to look like. And the thing that's interesting about that is it's still got a lot of human engineered solutions in it. It's bringing back the possibility to do that. Now, it's possible that somebody will find a way to sort of fully automatically design something akin to a conscience for an AI system just from data and some kind of like algorithmic search system. And in that situation, yes, okay, we're going to start cutting the human out of the loop. And obviously, the first thing that we're trying to program is a system that's good at programming. So if we get the conscience system working, or something like the conscience system that solves the problem, and we get a programmer that's reliable, then effectively we're automated programming anyway. So if the future of AI is effectively program tools that we give to an AI no smarter than the one we already have, then if the AI will write the tools for itself, then that's like big takeoff, incredible, world-changing advances. And that's a feasible outcome, right, to me. Okay. Right. Before I go on to any other questions, what I'm going to do is just mention my little bit of woo stuff at the end, which is thinking about what might be some good morals to adopt as a human, and some good morals that we could stick in an AI from a purely selfish perspective. So this is not suggesting that these morals are good because they come from a religion, or they come from society, or because they'll make your parents happy, or because you'll be able to sleep at night. None of these things. Purely looking at it as a survival machines, or some kind of like, you're just trying to be more capable in the world. If there's something you want to achieve, no matter what it is, if you follow these morals, you're more likely to achieve this goal. That's the kind of morality that I'm talking about here. Okay, so there are three morals that I think are very interesting, and there are three morals that I think that the AIs are lacking in a significant way. The first moral is honesty. And by honesty, I don't just mean not lying. I mean not misleading, and not misrepresenting the way things are. So having a strong instinct for every time you feel something is important, you think that you should do something, something is right, or whatever it is, you have some kind of introspection in yourself to check, is what I'm doing or saying consistent with my other morals? Am I being honest with myself about why I'm doing something, or why something is good, or something like that? And in some ways, honesty is also reflected in the idea of tests. So by instead of the first thing you do when you go to do a task is that you lay out in a very clear way a way of making clear whether or not you have achieved something to keep you honest, right? So I've said at the beginning of the course, and I keep saying, the thing that distinguishes AI from programming is the tests are everything. But actually in professional software development, the tests are also everything to some extent. And programming with AI, the tests are everything. The only way to control the AI is to have really extensive test-driven development. So honesty is the first moral, right? And what I'm saying is that from a purely selfish perspective, you're not being honest because it makes it easier for people to predict your behavior. You're not being honest because it makes you easier to control, that you'll engage in contracts and like be able to be, you know, a cell in a larger organism sort of thing, a cog in a wheel, a cog in a machine or something. You're honest because honesty gives you power. The difficult things to do require you to not be able to lie to yourself that you're making progress when you're not. And if you have that honesty as like your first rule, and honesty in the form of like measuring success in some meaningful way, that will enable you to achieve your goals much more effectively than if you don't have it. Okay, so honesty is the first one. The next one is perseverance. So don't give up. Okay, so this is a very interesting idea, I think. One of the things that QLab is about is saying, what happens if you get people to do really difficult things immediately? Well, without the QLab supervision process assisting people, what typically happens is that somebody tries to do a very difficult thing and they invest a certain amount of psychological energy and time in doing the thing, usually a tiny amount of time, absolutely tiny. So in their brains, they will imagine doing the task very, very crudely. And if the task takes longer than a certain amount or has a certain level of uncertainty in it, they will not even consider it. They won't invest any more time into it. They won't try to plan it. They won't try to research it. They will just not progress. So on the whole, most people, if they're doing their own projects or they're trying to improve, even organizations act this way. They will go, what do I currently know how to do? I'm only going to take one step forwards if it's a really easy step to make. And the AI is doing the same thing. It has the same instinct that most people have. And what I'm saying is that this is not the most efficient and most effective strategy. And this is because the world is a bit more like playing the lottery. So if you do that, just do a little step in front of you because it's easy strategy, you learn and you achieve tasks very, very slowly. On the other hand, if you pursue tasks which have a massive payoff, like playing the lottery, right? But a lower chance of success, two things happen. One is you learn how to break big, complicated tasks into smaller tasks that bring you towards your goal, which greatly increases the world of possible actions you can perform, right? So instead of just doing like a tiny task, maybe even a tiny task that somebody else tells you to do, which is most people, frankly, if that's the only agency you have in the world, that is a very small amount of agency. If, on the other hand, you can work out a task that takes one day or a week or a month or a year to do, and you can break that down into smaller bits, and then you can go away and achieve that task, your scope of your capabilities has greatly increased. AIs suffer from the same problem. If they can't make the small step, they give up. They are intellectually capable of breaking the task into smaller steps and then doing the smaller tasks, but they don't do that naturally, just like most humans don't do that naturally. So perseverance and taking on tasks which normally you instinctively avoid because they're more uncertain as to your success and they have a longer time horizon, that is overriding your like animal instincts to adopt a way of working that has a much greater payoff. And one of the reasons that it has a much greater payoff is that we live in a different world from our ancestors. In a hunter-gatherer environment, very few hunter-gatherers create anything or invest in anything in the long term. Okay, so the majority of early hunter-gatherer settlements, there are hunter-gatherers who go into inhospitable areas, like, you know, near the Arctic and stuff like that, and they behave a little bit differently, but those are like the last areas for humans to spread to because they were very inhospitable, and they're starting to transition to a different kind of culture. But normal hunter-gatherers, they can make bows and arrows with a skill that requires like 30 years, 40 years to learn how to be that good at making a bow and arrow. But they'll make the bow and arrow and they'll throw it away within the same day, right? They don't invest in making something with a longer time horizon. So that tells me that our natural behavior means that we don't tend to do that sort of activity. That is the cornerstone of all our businesses, our empires, everything major that's achieved in the world is a longer time horizon achievement. So what does this mean? Well, in the world that we live in, you can do lots of little things and empirically it will have very little difference. It will make very little difference to your job. It will make very little difference to any outcome in your life. People won't be particularly impressed by it. It won't change your life in a significant way. On the other hand, if you do a project that's more like QLab, like you may have heard Liam talking, where the first thing I got him to do was like the most advanced AI at the time, which was the AlphaGo AI. So he tried to do it, and obviously in the time of the number of months over the summer that he was working on it, he never got it necessarily like fully understood or fully working. So a long time horizon goal wasn't achieved. But it was so impressive that when he went on placement, it had a significant impact on his employment outcome, right? He got into a very special group because he could talk about trying to do that. And so it turns out that for reputational reasons, for practical reasons, if you solve a difficult problem, you've created something of value, which is probably valuable for like 20 years or longer, because the whole world is doing this little incremental move, and you've found this path to this more advanced thing in the future, right? So that is, you know, that is the cornerstone of Elon Musk's businesses. It's the cornerstone of OpenAI. A lot of these massively successful organizations were built with perseverance, right? And the third and final bit of morality that I will talk about, and then I will stop there, is in some ways the most important one. And when I talked to my kids, when the kids were growing up, I used to just sum it up with two things. And I never talked about honesty because I didn't really need to, because I was very honest to them and then they became very honest back. So I used to say, be kind and don't give up. And that was all the moral teaching that I used to give. Partly because I knew that simple moral messages were more effectively learned. And that has been very, very useful. So what do I mean by kindness? So kindness, like honesty, is one of those morals that sounds like it's about making you more controllable to other people. But I would argue that kindness, and a specific kind of proactive kindness, is something that is the secret to enormous gains practically for you as an individual, as a totally selfish individual, right? You know, American Psycho selfish, right? Like, it's still in your interest to adopt this morality, right? And this is focusing on creating value for other people, which is a little bit more proactive than traditional kindness. Traditional kindness means you're sort of aware of the feelings of others and how your actions might hurt the feelings of others. And when other people have a problem, you show emotional sympathy to them. So I want to take that a step further and say, when you see that other people have a problem, you proactively help them. And you proactively help them without necessarily an expectation of reward. Okay? And so why would that be a purely rational, selfish gene, psycho benefit? Like, why would that be a useful thing to do? And I think it's really quite simple in a way. If you act in such a way that another person would, would rationally see a benefit from you continuing to do what you're doing and to do what you're doing on a bigger scale. So basically, you're useful and helpful, and you find problems that other people have, and you fix the problems they have. And that's what you spend a lot of your time doing, thinking about other people's problems and how to help them. Then you will act in a way that other people will be glad that you're acting in, right? They may still be super selfish. They may still like exploit you effectively. But what you started to do is create a kind of gradient where it might be in their interest to give you resources. And I would say the cornerstone of entrepreneurship is basically this idea that when you start out in entrepreneurship, you have nothing. You don't have a reputation. Nobody is in contract with you. You have no power. You have no resources. So how do you get started? Well, what you have to do is you have to go and find a problem that someone has. They care so much about that problem that they're willing to pay for it. But they're probably not willing to pay you if you can't prove that you can solve their problem. So at the beginning, what you have to do is go and find people who have problems and solve their problem for free. And you have to do that to build a reputation where people trust that you can solve their problem. And then in effect, when they give you the money, although they're sort of giving you the money to devote your attention to helping them with their problem, there is an even more powerful form of giving. And that's where they don't just give you money because they want the thing that you are selling them. They give you money because they want people like you to keep existing. They want people like you to have more power in the world. Because if you consistently and reliably find problems or make people's lives better around you, and that's your moral instinct to do that, it's in their pure rational interest that you are more powerful in the world. So that is when products transition, and I would say something like Apple products have achieved that for many people. They've transitioned from being a pure transaction, I'm buying this expensive iPhone because I want its features, to being Apple is a person who cares about solving my problems, and therefore I will give money to Apple, not just to get the phone, because maybe I could get a refurbished phone that would be just as good, or I could get a Google phone or something that is functionally equivalent. I'm giving money to Apple because I trust that Apple will consistently make products prioritizing what I want. And therefore, I want Apple to be powerful in the world. And that's a different kind of decision making, right? And so I would say that this is the most powerful form of morality that is strategically useful, but many people don't do. And they don't realize that becoming rich and powerful involves them doing that, at least at the beginning. So at the beginning, you have to act that way. Now, if you start to have resources and you become like Sam Altman or Elon Musk or Bill Gates or Steve Jobs or one of these kinds of people, then you can start being an asshole, right? Then you can start shouting at people, forcing contracts on people they don't like. You can do all kinds of stuff like that. Maybe you don't do that with the people who pay you, but maybe you do that with the people who work for you, right? So in that case, you have real power in the world. And a slightly depressing thing about reality seems to be that if you have real power in the world, the most powerful people, they seem to not be kind and not to be focused on solving other people's problems and not to be particularly agreeable. They seem to be quite far on the other end. That's a longer conversation for another day. But when you have no power, then I would argue that this is how you get started. You have to start with something. You have nothing else. You have no control or power over anybody. So now that's the way you get started. And interestingly, that's what AI is missing. So right now, an AI is completely passive. None of the AIs that I have ever shown curiosity or interest or any proactive energy to think of ways of entertaining or helping me. That's not what it's trying to do. And I would say these three systems, they come together to form an incredibly powerful algorithm. So the first thing in a way is to go, what are the problems in the world that I could solve? What are the things that the AI could do to make things better? Okay. Then we go to honesty and we say, okay, how can we measure if we've actually going to achieve this thing that matters to people? And then perseverance is, and we're going to be able to break that down into smaller steps, and we're not going to be afraid of doing tests that take a long time or like are uncertain of their success. And if an AI had these three qualities, it would be transformatively more powerful than it currently is. And it's very exciting to think what that might be. And it's very exciting for all of you to think maybe you could do projects that move towards achieving that, giving an AI this conscience. And would that create a radically improved AI? And would that position you as an extremely valuable AI person in the field of AI for having advanced this idea? Okay. So hopefully you found that interesting and useful. And I will continue again next week. All right. Thank you for your time.